Hi, y'all. Welcome back. Today we're going to be talking about liquid density. The last couple of days we've spoken about percent error, accuracy, and precision. We've also spoken about regular and irregular density. Today we're going to be talking about liquid density. So let's get going. Let's recap. What is regular density and what is irregular density? You need to be able to distinguish the two. If you're not able to distinguish the two, it's gonna make it a little bit difficult adding the third density in. So remember, regular density, we're able to use length times width times height. We have real dimensions because we have straight lines, straight edges. Where in irregular density, our object is curved, so we have to use water and a graduated cylinder to be able to determine to be able to determine the volume. So regular density, length times width times height. Irregular density, we're using water and the graduated cylinder to determine the volume. So when we're talking about liquid density, right, we're going to take the mass of an empty graduated cylinder first. Now, when it comes to liquid density, you need to remember that volume can be measured in centimeters cubed or in milliliters. So whatever milliliters you get for your liquid, that is your volume, right? So just keep that in mind. So as we find out the density for a liquid, we're going to take the mass of an empty graduated cylinder. We're then going to pour the liquid into the graduated cylinder and take the mass of it again. With these two masses, we're going to go ahead and subtract, because what we're doing is subtracting the empty graduated cylinder from the graduated cylinder and the liquid. That would only leave the mass of the liquid left. Once we have the mass of the liquid, take the amount of liquid that is in the graduated cylinder, meaning record the volume in milliliters, and then we're still doing density equals mass divided by volume. As usual, you already know it is easier said than done. So let's go ahead and practice this out real quick. And we're going to come back to that page in 1 second. So, a student collected the data shown below to determine experimentally the density of distilled water. The mass of the graduated cylinder plus the distilled H2O sample is 163. So that's both the liquid and the graduated cylinder. The mass of the empty graduated cylinder, 141 grams. The mass of the distilled H2O sample, we don't know that. And then we have the volume of the distilled H2O sample. That's how much distilled water is in the graduated cylinder. And then the question asks, based on the data collected, what is the density of the distilled water? So what we're going to do first is we have been provided two masses. Now we don't know the mass of the distilled H2O sample, meaning we can't use density, because remember, density equals mass divided by volume. We have the volume. The volume we know is 25.3 milliliters. I know this is volume because it says it, and I also know that volume has can also have units of milliliters. Now, we don't have the mass of the distilled water. However, we can determine the mass of the distilled water by subtracting the mass of the graduated cylinder and distilled water from the mass of the empty graduated cylinder. So we're going to take 163 and minus it by 141 grams. And when we do that, we get 22 grams. Now, with 22 grams, we now have the mass of the distilled water. So we can go back and figure out density. Earlier, we already determined we had volume. Now we have mass as well, which is 22 grams. So we're going to take 22 grams and divide it by 25.3, and we should have our density of our distilled water. And we get our density to be 0.869 grams per milliliter. Now, As we look at the answer right here, we don't see exactly 0.869. So let's go ahead and round it off. So when we do round it off, I like to draw the rounded off squiggly line. We get 0.87 grams per milliliter. And is that answer there? Yes, it is. That answer is B. All right. Now, I also wanted to give you this last slide to help you figure out what to do when you're solving for density, right? So first, recognize the problem. Are you dealing with liquid, regular, or irregular density? You need to determine that. Find the mass, right? Find the mass. Underline that value. Now, if they don't give you the mass, that means you're most definitely working with liquid density, where you have to subtract the masses. Find the volume. Circle the value. Now, once again, if they don't give you outright the volume, that most likely you're working with the irregular object density problem. Then always remember mass divided by volume. I've given you this triangle here because I know it's really helpful for some of you. So let's deal with one more problem. And this problem is a little bit different. So the density of a copper is 8.96 grams per centimeters cubed. What is the volume of a 43.8 gram piece of copper? Now look, this is different. Based on the units, I can tell you that already that this is a regular density problem. How do I know? Because my units give me grams per centimeters cubed. And I'm going to go ahead and record the information I have. They're saying density equals 8.96 grams per centimeters. And then they're also telling me that my volume is 43. Oh, they're telling not my volume, sorry. They didn't give me volume, so that's going to be a question mark. They're telling me my mass is 43.8 grams. So I'm going to have my triangle here. And easier way to remember this is DMV. That's where you're going to get your licenses and stuff. And you are multiplying the D and the V, and you're dividing the M and the V. So the thing is, I want to find the volume. So for me to find the volume, if I put my finger right over the V, for me to find the volume, I need to take my mass and divide it by my density. So my mass is going to be 43.8 divided by 8.96. And when I do 43.8 divided by 8.96, I get 4.88 as my mass. And the easiest way to check this out is go ahead and multiply. Let's go ahead and do the mass divided by volume to see if you get the density that they gave you in the problem. If you have any questions, I hope to see you during the live session so you can ask them. And please reach out to me or Mr. Schwartz for any assistance you need. Go ahead and have a good day, guys.